I would like to invite Sarah Noble, Jim Spann, and Kevin Sato to go ahead and fire up your technology. And we're going to hear some division updates, and it looks like we're going to hear from Dr. Sarah Noble to lead us off. Take it away, Sarah. And before we do this, I just want, for everyone's essay, we're going to have these three presentations coming up, and then we're going to have a 15-minute question and answer period for all of the next three segments. That's going to be the SMD Division Updates, the SMD SEO update that Joel's going to come back and talk about, and then we're going to have Julie Robinson talk about some HEO updates. Then we're going to have Q&A for that block of talks. Okay, sorry. Take it away, Sarah.
Thanks, Dave. Can we go next slide? So I just wanted to start out by talking about, just reflecting a little on like what a great time it is right now to be a lunar scientist. We have so much going on, right? From orbit, LRO, Themis, Artemis up there still doing their things, going strong. We have some CubeSats that are coming up. We've got these CLIPS missions twice a year. We've got Viper coming up, and we've got the ENCSA folks in the lab learning lessons from Apollo. So left and right everywhere you look, it's raining moons, which is awesome. It's a great time to be a lunar scientist. Next slide. A little bit on Viper. Viper is moving forward. It is difficult to build a mission in the middle of a pandemic. That has been challenging, and on top of that, I feel like this poor team, right? They've had to deal with wildfires in California. They've had to deal with floods and power outages in Houston. Sometimes it feels like Mother Nature is conspiring specifically against Viper, but the team is moving forward. They're doing great. They passed their KDPC in February, which is great. It means that they have now been confirmed officially as a mission, and they're still on track. They're moving forward to get to the moon at the end of 2023. I always like to show hardware pictures when I can. In the picture on the right there is an image of not flight hardware, but a model of the Griffin lander that recently got delivered to JSC from the Astrobotic folks, and so JSC folks can start working with that and figuring out how to integrate the rover with the lander and working on egress issues and whatnot. So it's good sign of progress. I always like to see hardware. Next slide. Simplex, like I said, we've got some small stats that we're working on. So Lunar Map from the Simplex 1 Roses call is planning to launch on Artemis 1, and they are just about ready to deliver. I think expected in June. So good progress on that team. Trailblazer is our Simplex 2 AO selection. They are also doing great. They also just recently passed their KDPC in November, and they're looking to get a ride share with IMAP. That's actually a heliophysics mission, so we like to partner with the other divisions every chance we get. They're doing great too. Next slide. Note that we actually just had selections for participating scientists for the Korean Pathfinder Lunar Orbiter mission. This is Korea's first deep space mission. They're looking to launch about just over a year. And so you can see the list there of the participating scientists that we've recently selected. This is very exciting for Korea, and I'm happy to see some of those guys get to participate in that mission. Next slide. A little bit of update on ANCSA. ANCSA, our Apollo Next Generation Sample Analysis Program. This is a program looking at some specially curated Apollo samples, and in particular, some that have never been looked at before. Including a double drive tube where the lower half of the drive tube actually was sealed on the lunar surface. It's one of our three remaining, apologies for Luna, three remaining lunar samples that haven't yet been opened. We have now opened the top half of that drive tube, not the sealed half, but the upper half, which hadn't been opened. We opened it just before the pandemic hit, and so we had just started to get some samples out. The very earliest samples, and then they sort of got shuttered, but they have been able to get back into the lab late last year. They were able to get back in the lab and start processing again, and so now those samples have started to go out to the team, and they are working hard on them. There were special sessions at both AGU and LPSC with some of their first results, some really exciting stuff coming out in science, and also in terms of lessons learned about how we curate things. And whether the way we did it during Apollo is the right way or not, and so that's some good things too. And we are working on getting that lower core opened. It's a delicate thing. You can only do it once, and so we're being very sort of cautious and careful. We're working with ESA to develop a gas extraction tool so that we can pull those gases out that have been hopefully saved in there since they were on the moon. That tool should be delivered this summer, I think, and so I think we're looking for sort of late summer, early fall to open it. I have to sort of work that around hurricane season. So we'll see exactly on the timing of that, but we're getting close to being ready to do that. So that will be some excitement coming up. Next slide. And this is just a gratuitous shot of some of our ANCSA scientists in the labs doing their thing. It's so great. We've been able to get these samples out, and they've been able to get back in their labs. And I know it's been a really challenging year out there particularly for all the lab scientists. And it's so nice and exciting to see them getting back into the labs and actually getting to their hands on these samples. Next slide. Some upcoming things, right? So we've got Dolly proposals, right? That's an annual call. I will note that this year we actually added language that we are particularly interested in things that are responsive to the Artemis SDT report. And so you can see many of the ways that we are sort of integrating that SDT report into every aspect of Artemis across the board. Step ones for that were received already. Step twos are due in June. LDAP 21, those are it's the bookends of Rose's 21, right? LDAP proposals are generally late. They are not due until December, but I wanted to point this out that this year LDAP is going dual anonymous, and so you might want to start writing your proposals a little earlier so you can get all of the steps down for dual anonymous and make sure that it's written in the right format for that. So just a little heads up there. A reminder that many of our other PSD programs are also open to lunar proposals, SSW, PDART, PSTAR, EW, the list goes on. There's plenty of places to put your lunar research out there. I know I've gotten a lot of questions about the Viper COI call, and I want to assure you, I know I keep saying it will be out very soon. I actually mean it this time. It will be out very soon, within days. We are almost there. I was hoping to get it out in time for this workshop. It didn't quite happen, but it will be out within days. And this is a slightly different thing than a participating scientist program. It's a little bit of a subtle difference. We are adding COIs now, sort of earlier in the mission, and providing them the opportunity, to really get integrated into the mission, as opposed to a participating scientist program where we usually bring them on sort of late. These are expected to be full COIs. SurveyCan, the survey folks will be talking later today, and I don't want to steal their thunder, but we are planning to have a SurveyCan 4. We're working on that. They are going through a senior review right now, and we'd like to be able to incorporate the results of that review into the CAN, and so we are expecting to put out a draft of that probably early next year. We are considering participating scientist program for PRISM deliveries. You heard Joel talk about PRISM, right? As we sort of ramp up our CLIPS opportunities, right? The early ones were sort of random collections of instruments, but these PRISM ones are much more focused. They're almost like small missions in and of themselves, and so we think it is appropriate perhaps to have a participating scientist program. It's something we are thinking about. No timeline for that yet, but just wanted to give you guys a heads up that it is something on our radar. And finally, the Artemis science team and the instrument calls for that. And you heard Joel talk a little bit about that, and you'll hear more from him about that as well. But there's no timeline established for that yet, but I would like to talk a little bit more about where we are with our planning for those things. Next slide. So the Artemis SDT report is out and available. Renee will be talking about it later this afternoon. And we are working on planning for a competed science team. We got all that great input in February from our lunar surface science workshop session on real-time science operations. We really appreciate that. We're going through that right now, trying to figure out what a science team will look like. But in the interim, we actually we found we are in need of a more rapid response team. As we are going along, we are getting a lot of questions from across the agency about science, about things that science cares about as they are developing the Artemis architecture. And this is great. I'm really happy to see that the engineers are coming to us with questions. That's fantastic. They're not just going off on their own and making assumptions. They actually are really coming to science, and that's great. But the problem is that there's no real mechanism for that now that the SDT team has been disbanded. And so in order to make sure that the architecture is really enabling and enhancing the science objectives that we have laid out in this report, we've put together a rapid response team. Next slide. Which we're calling the Contamination and Research Integrity Rapid Response Team. It's a bit of a mouthful. That title is because this is in some ways similar to a contamination control board, but it has a bit of a broader mandate than that. So CARI, as we call them, are going to be able to provide that interim guidance, that sort of down in the weeds level that the report was not able to get down to, so that they can provide these answers throughout the Artemis architecture as they are called upon. So for things like right now, one of the questions they're dealing with is like, what materials can we make our tools out of that the scientists are going to be okay with and aren't going to cause problems for scientists, right? And so they're on the ground and ready to answer these questions on the timelines that the Artemis folks need them to. And you can see the team here covers, they're a fantastic group, and they cover a wide array of expertise, but they don't necessarily cover everything. And so they are our team on the ground, but they are allowed to reach out to, across NASA, across the wider community, through XMAG, through League, other community groups. And they can even request that we spin up special action teams or whatever they need to get the answers that they need to feed back into the engineers. So this is our interim solution to provide an authoritative voice to speak back to the engineers. Next slide. Okay. So, as I said, we don't yet have a timeline for developing an Artemis science team or for the instrument calls, but we have been thinking a lot about it. And so, while none of this is set in stone, I just want to be open about where we are in this process and what we're thinking about. We're sort of thinking about this in two phases, right? There's the initial sortie phase, which will be the first, 1 or 2 landings. These are more sort of Apollo style, short duration, standalone activities. And eventually we'll get to a sort of base camp build up and operation phase, which is going to look different. And I think the science team needs for that are going to be very different. And so we're going to sort of think about this in 2 phases. For this sortie phase, we do expect to have a call for hardware that will be based on priorities in the report. We don't have a timeline for that yet. And then for the geology team, apologies. For the geology team, the geology experiment, as it was called during Apollo, we do expect to have a call for that. That will likely be for a team rather than for individuals. Sort of think about it like an instrument team, but the instruments are the astronauts instead. We don't have a timeline for that yet. That will be, a small sort of core team that will be added to with some NASA internal folks. There will be a mix of internal and computed roles. And then we will also supplement that as we get closer to a launch date with a participating scientist program to sort of broaden and widen those numbers. And I think that's my last slide. Yes, awesome. So I will turn it over to Jim Spann.
All right. Thank you, Sarah. Really appreciate that good overview. What I'd like to do, if we go to the next slide, is talk about heliophysics and the role it has, and it sees the value of the participation in Artemis and Gateway. And so just a little bit of a summary that heliophysics really addresses a lot of the mechanisms and activities that go on between the celestial bodies and the solar system bodies. And so, and furthermore, space weather is kind of the applied expression of all of that good solar and space physics. Next chart, please. One of the things that Sarah mentioned and will be discussed a little bit later is the Artemis science objectives from the SDDT Artemis 3. I just want to highlight that 4 of the 7 objectives really do have relevance to the heliophysics type of science, and we'll get a little bit more into that. Next chart, please. The other aspect is that there are many, the CLIPS is going to be discussed a little bit more in detail. And so this is kind of just the, as I understand, the launches that are getting ready to take place. Next slide, please. In the first 2 years, though, we noticed that there are many of these surface science payloads that have relevance to heliophysics. And that addresses the plasma environment, the interaction of plasma and dust, as well as an understanding of the deep impact of solar wind on the surface of the moon. And so next, I'm not going to read through all of these, but just for your reference, next chart, please. As you can see that there are several of these, and on each of the manifests, both in 21 and 22. Next chart, please. I want to talk a little bit now about the gateway. Obviously, the gateway is not on the surface of the moon, but it certainly supports that activity. And there's a tremendous amount of science, particularly in heliophysics, that can be done from the gateway. Next chart, please. As part of the activity, Gateway looked at some strategic goals. Goal number 3 was really focused on what science and research could be done from the Gateway. Next chart, please. In that goal number 3, there are 3 sub-objectives that totally focus on heliophysics, and it's not only characterizing the natural and induced environment, but also about how the dust interplays with that environment as well. And so I've highlighted 2 of those. This is a long-term goal and objectives for science, heliophysics science on the Gateway. Next chart, please. And so not only is it the natural environment, but there can be fundamental heliophysics investigations that can take place, that can be conducted from the Gateway. And some of these are clearly associated with being in the vicinity of the moon, but many are not. And I've highlighted a couple there where the Gateway can serve as a platform for imaging and remote sensing different regions of space, not only back toward the Earth, but looking at exospheres of the moon and the Earth and deep space. And then finally, an opportunity to take advantage of the architecture that the Gateway provides with various components as they go and deliver payloads and services to the Gateway. Some of those platforms can be used later on as they're discarded to do further heliophysics science. So we see the Gateway and the surface science at Mars, at the moon, as a great proving ground for capabilities, but also a great laboratory to conduct heliophysics research that cannot be conducted anywhere any other way. Next chart, please. On the Gateway, there will be 3 science payloads that will be launched initially with the Gateway, along with the HALO and the PPE modules. Next chart, please. The moon, as it passes through the various regions in space, it spends about 3/4 of its time in the solar wind, but the other quarter of its time is in the deep magnetotail. So from a heliophysics perspective, this offers a laboratory environment to do some research. And so we've got 3 goals established for a payload that NASA Heliophysics Division is going to be flying on the Gateway. And that is really to determine the mechanisms of solar wind mass and energy transport, and then the characterization and topology of ion composition in the deep magnetotail. And finally, more of an operational and applied aspect is to establish the observational capabilities for an onboard Pathfinder payload that would measure the local space weather environment to support deep space and long-term human exploration. And we see this as a pathfinder, or as a first step in terms of understanding what might be needed for deep space exploration when humans go off of the Sun-Earth line as they are at Mars initially, and need to essentially take care of themselves by understanding what the environment is. So what are the capabilities that need to be that the astronauts need to have on board with them that they can handle by themselves? And we are using the Gateway to serve as a proving ground and a pathfinder for that. Next chart, please. So this payload that we have on there is a typical solar wind / space weather payload. You can see the instruments. There are 3 plasma instruments that measure plasmas and particles, and then a magnetometer, which provides good context in terms of understanding the plasma environment. Next chart, please. So Hermes, the name of this payload, essentially concentrates on understanding the causes of space weather as driven by the sun and modulated by the magnetosphere as it goes into detail. It's important to note that this capability is being used in concert with an already existing two spacecraft, Themis Artemis capability that's in lunar orbit. And the idea here is that those two spacecraft, the Themis/Artemis spacecraft, are in an equatorial orbit or in the ecliptic plane around the moon, whereas the Gateway is going to be in a near rectilinear polar orbit. And therefore, by using the two Themis Artemis and the Gateway, we essentially have three platforms to measure the solar wind and the space environment in 3 dimensions, which opens up a lot of structure and acceleration processes, investigations that are not possible otherwise. Next chart, please. I'll finish up by noticing that on the Gateway, or making note that on the Gateway, we have a sister payload that ESA is providing. It's called the European Radiation Sensor Array. And while the Hermes, the NASA Hermes payload focuses more on solar wind properties and energies of particles up to the MeV range, the Ursa payload captures the higher energy ranges going up more into the radiation. And so together, these two payloads provide a broad observation capability of the space environment in the cislunar space. And inclusive of this is that much like Sarah mentioned earlier about having interdisciplinary scientists join payload teams, we are doing the same thing with Hermes and Ursa. In fact, with Hermes, the selection is going on right now. We're in the process of reviewing the proposals that have been received. These are by design very international teams. ESA is about to release its own call, again, with international teams. And so once the selection is made of these interdisciplinary scientists, a larger international science working group will be formed to really maximize the science output of the observations and the investigations that both of these payloads will perform. Next chart, please. And so here are the Ursa science objectives. Again, they're really focused on radiation and somewhat more operational aspects. And final chart, please. So this is just kind of to give everybody just a visual sense of what the possibilities might be. Obviously, this looks like it's on the moon, but you know, it could be on Mars, where at some point when we have humans doing research on the Mars, they will have the capability to pull up their tablet, and much like we do on our iPhones and check the weather before we go out, they will be able to check the space weather and understand what's going on during that expedition that they are planning. And with that, I will turn it over to Kevin.
Hello, everyone. Next slide, please. So as you know, I'm going to be focusing on the biological and physical sciences division activities as it relates to lunar science. And as you know, we have been very focused over the last 20 plus years really on conducting experiments on Earth as well as in low Earth orbit in order to understand biological and physical systems responses to this environment. And so heading out beyond LEO and towards the moon is really a new era and entity for us. And so we're really interested in making sure that all our objectives for this area of research are well defined, as well as integrated into the utilization mechanisms for studies. And so from the perspective of fundamental lunar science, we are looking at it from the perspective of life sciences, fundamental physics, and physical sciences, as well as how can we apply this information to the human research program, as well as to other divisions across NASA. Next slide, please. We look at our work for lunar research in a very integrated manner. from fundamental science to space technologies, Earth benefits, as well as human exploration. So what we're interested in doing is really taking what we learn from a fundamental perspective and being able to translate and apply that to many different areas that will enable advancement of human exploration on the moon for sustainability, as well as beyond for Mars. Also, we'd like to advance and build our communities around lunar science, as well as to inspire and educate and train our next generation of engineers and scientists, operations people, who are really going to be the ones that take us beyond the moon and to Mars. Now, when I do say this, it's not necessarily that we are going to forget about the International Space Station. When I also talk about an integrated lunar science research, BPS is looking at it from the perspective of both Earth-based analogs to LEO work on ISS and other low Earth orbit platforms, and all the way out towards the moon. And how do we use each of those platforms in order to really understand biology and physical sciences and fundamental physics as it applies to going outside of low Earth orbit. So we're not leaving anything away. We are going to become inclusive, again, of all the work that we have done and applying it out towards the moon. Next slide. So there are multiple ways to conduct science in the lunar environment that we've heard, and the BPS division is certainly going to take advantage of opportunities to put research on every single vehicle that we can. This is a whole new area, and it's an area that our scientists have been really excited about doing, to be able to actually do research in the true radiation environment of deep space, as well as to understand partial gravity and physical sciences and life science responses alone and in combination with the space environment. So we will be looking to do research on other areas, and as part of that, and as part of being part of SMD, we are being integrated into all of the efforts that are currently going on in NASA in order to understand what are the objectives for utilization, scientific utilization on these platforms and at the moon and around the moon in cislunar orbit, and also how we can bring our science to all sorts of different areas for what we are interested in looking at. So on the right side of the slide are really a lot of the groups that we have been working with to really bring forward our utilization efforts in a manner that's for our science, but also
Hey, this is Dave jumping in. Kevin, we lost your audio. It just all of a sudden went away. If maybe you could check a button that I don't see a mute icon next to you. It just your voice went away. Try again.
Can you hear me now?
Yes, sir. Please continue.
Okay, great. And so we are also looking at it from an integrated perspective with all the other divisions of the science that's currently going on in those other areas, because there are crossovers and synergies that we're seeing. Next slide, please. So as part of this work, we were involved with the Artemis 3 Science Definition Team report, and you'll see that objectives 5, 6, and 7 are areas that our science definitely is applicable to, but also there are other areas that we may be applicable to based on our physical sciences work. So I really encourage everyone to please take a look at the report because there's much, much more in there than just the 5, 6, and 7 objectives that we apply to. Next slide, please. And these are just some examples of those. There's cross-discipline objectives that may apply to physical sciences in terms of understanding and characterizing the origin of lunar and polar volatiles, as well as observing the universe and local space environments from a unique location. As you can see, there's many different areas that our science could be involved. Next slide, please. From specific areas that we did trace to our 2011 decadal survey, conducting environmental science in the lunar environment, a lot of areas are applicable to research that our physical sciences group is doing. Next slide. This is just a much larger list of that. And so you can see it's just not one-sies and twosies things. It is a broad area of physical sciences that is directly applicable to research on the moon. Next slide. From a life sciences perspective, the research is there. It is in areas that some of you will recognize as what we have been doing in low Earth orbit, but now it's expanding out to the moon. And many of these are at very high levels that will apply to many of the work that we're currently doing. Next slide, please. So what are we currently doing? We're doing quite a bit in terms of the activities that are currently in progress. For the Gateway International Partner Agency Discipline Working Group, this is a group that's working on looking at early utilization phase payloads. And we do have payloads that we're working on or have been accepted. As Jim mentioned, there's URSA and there's also IDA, which is the internal dosimetry array, so that we can characterize and understand what the radiation environment is outside the Gateway as well as inside the Gateway as metadata, but also just to really understand the radiation environment. We're also looking at microbiology from the point of the microbiology of the built environment and its ecosystems, and also a package called GRAB, or the Gateway Research Accommodations Bag, where passive experiments go in for study for the early utilization. We're also working with our international partners on defining science objectives in multiple areas, which will help define utilization capabilities. And again, as well as a roadmap. And this is also in collaboration with information we've received from both the European and NASA this should be in astrobiology and planetary protection. So it's very comprehensive. And also we're participating in the utilization coordination and integration groups, which you'll probably hear more about from Julie Robinson. And again, this is looking at what is specifically going to be needed in order to utilize the lunar surface to do research in terms of capabilities and facilities, laboratories, and other things. So we can actually do comprehensive studies from everything from simple organisms and out. Next slide, please. We've been participating in looking at what the tactical assessment teams are doing to develop figures of merit for where to land. One would think that DPS science is landing agnostic, but we do have areas that physical sciences will likely want to go based on work they're looking at in terms of mining and extraction for ice or minerals or other sorts of compounds. As well as we're moving into looking at utilizing the commercial lunar payload services. We recently did a presentation at the invitation of the CLPS office and SEO to the CLPS vendors to provide them with our unique needs for life and physical sciences, especially the life sciences in terms of science payload, change out, power needs, and other things. So our communication and our voice is definitely being heard. In terms of early missions, we do have a mission on Artemis 1 called Bioexperiment 1, and it will be returned to Earth. There was a call that went out, and it'll be both plants and microbiology, seeds specifically for plants, as a Pathfinder investigation study. And this is being managed out of Kennedy Space Center. Next slide. Space biology itself has began to pivot its research. It will remain in low Earth orbit, but as it moves out to the moon, it is beginning to take a look at specifically what areas of research are going to be focused on and which model organisms they are going to use. And this is to maximize our return based on the funding we have and also to begin to move ourselves forward. Next slide. And again, what I wanted to really bring up in this slide is that there's a ROSES 21 Amendment 12 call that's going to be coming out for draft science text for community comment on a Lunar Explorer instrument for space biology application. And this is going to be related to CLPS, and it will be released no later than May 15th. And so go to Inspires if you want to see what's currently on there and make sure you're subscribing. But we definitely, they are beginning to move in space biology. Next slide.
Kevin, we're going to need you to wrap up pretty quick here. We're getting several minutes behind. Thanks.
No problem. And for physical sciences, there is going to be a lunar surface science research workshop August 18th to the 19th. So please, you should have received information. Otherwise, please go to the LPI website to find that information. Registration is currently open, and abstract call will be on May 3rd. Last slide. Next slide. And this is just information for that you can look at later related to funding opportunities and other things. So thank you.
Excellent. Thank you, Kevin and Sarah and Jim, for that nice sequence of talks.